So distributive property. Using distributive property to simplify algebraic expressions. Well, if we have basically the distributive property is multiplying whatever is outside of parentheses to everything on the inside. Well, first simplify the inside of the parentheses. So this is basically the idea here. Using the distributive property as basically first you're simplifying inside of the parentheses, and then you're multiplying whatever is on the outside of the parentheses to everything on the inside. So when I was writing the order of operations earlier, when I said that you simplify inside first, or distribute whatever's on the outside, this is what I meant here. So let's take a look at using this rule. So here, our problem is, the way we read it is A times, because there's no plus or minus in between what's on the outside of the parentheses. Whenever there's nothing there, that means that it's multiplication. So A times all of this, B plus C plus D. First we look on the inside to see if we can simplify anything, if we can. Is there anything we can do? If they were like terms, we could add them together, but they're different variables, so there's nothing that we can do, but if they were, if we had like a B here and then a 2B there, then we could add those together, but there's nothing that we can do here. Yeah, well, that's what we have to distribute now. And what distribute is, the property is what we were saying. take whatever is on the outside of the parentheses, multiply whatever is on the outside of the parentheses to everything on the inside. So that means we're taking this A. First we're doing A times B, which gives us AB. Whenever we have variables connected like this with no sign in between them, that means that it's multiplication between the variables. Okay, so now we've done that. We have to do it to everything on the inside. Everything. So we have to go to C now. It's a plus C. So A times C gives us plus AC. And then for our last one, again, there's a plus sign there. You have to be concerned with the signs when you're doing this as well. So this gives us plus AD. And that's as far as we can go. So that is our final answer here. So what we're doing again is taking whatever is on the outside of the parentheses and distributing, which means multiplying to everything on the inside. Okay, so again, we first look on the inside when we're trying to simplify. We cannot do anything with the inside because there are different variables there. So that stays the same. Now it's just a matter of distributing what's on the outside. We go to the first term. Let's take it and write it like this here. We're taking the number -3 times the number 5, right? And we're bringing back that x with it. So this will tell us that this is what? -15x, right? All right, let's go to the next term. Taking -3. So a negative times a positive gives us what sign? Gives us a negative sign. So now we're just looking at 3 times the 2. And we're joining in the y with it. So now that gives us what? So minus 6y. And that's as far as we can go. So that will be our final answer with that. Mm-hmm. 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 Okay, let's look at it that way. What I did was simplify the sign before, but let's look at it the way that you see it. Um, let's put the plus back here. Put the plus for that there, and then put the -3 back in there. So now,
So it's still the same, it's just a
hmm
different methodology.
yeah, yeah, yeah. I just simplified the sign before I did it. So, but it works out to be the same thing, because when you do 3 times 2, you get -6. So then you have the plus minus there, and plus minus becomes minus. So first thing we do is we look on the inside, see if there's anything that we can simplify. Um, is there anything that we can simplify? Hmm? But one of them is a square. So so when we have different powers on the variable, we still cannot combine them. Not when we're adding and subtracting. So really, there's nothing that we can do on the inside. Hmm? But the thing is that when we have different powers on the same variable, we can't combine them though. That's the thing. We cannot, and we have a section that's coming up where we'll look at that. But if this was just y, then we could combine. But it's a y to the second power, so we can't do anything to combine those two. So it's just a. Mhm.
So the power is considered a variable?
Well, the y is a variable, but the power, when we're thinking about simplifying or combining, they have to have the same power. And we have a section that's coming up that's going to deal with all of that. So, uh, but for our purposes, whenever we have different powers on the same variable, we cannot combine them. They will stay the same as they are. So that just leaves us with distributing, taking the 7/2 and multiplying it to the inside. So we take 7/2 and we multiply it to y squared. That's the first thing. So that's going to give us, keep in mind that we can change this into a fraction by doing what? Putting a 1 under it. So now we have 7y squared over 2. All right? And now going on to the second term, we have a plus there. So plus 7/2 times 6y. And again, we can put a 1 under this one and make it into a fraction. And what can we do before we multiply? Yeah, because 2 can go onto itself once, and it can go onto that 3, right? So let's just rewrite it first. So it looks like, well, both of them have a 1 denominator now. So we don't need to write the denominator. We just write it as 7 times 3 times y. Do that multiplication. And that gives us 21y. Different powers, so we can't do anything else with this. So that's our oh yeah, we do have one more to go. So when we have a positive times a negative, so that's going to give us a negative, right? And times a negative times a 2, because we already simplified the sign. So I didn't put the negative in front of the 2. All right, what can we do with that? Right, because this is like having that over 1. So 2 goes into itself 1 time. And now we have 7 times 1. And that's just going to give us minus 7 there. Now that's as far as we can go. All right, let's take a 12-minute break. Okay, so here we have an example where a rectangular field, a rectangular athletic field, is 200 feet wide. One portion of the field is 5x feet long. The other portion is 4y feet long. And what we want to do is find an expression for the area of the field. So we need to know the formula for area. Anybody remember formula for area of a rectangle? Okay, yeah, 1 times the width. Length times the width is equal to the area. For a rectangle, that is. Now our goal is to put this information into a algebraic expression. So we want to create an algebraic expression out of this. One way we can do that is first by, looking at what it's saying in the drawing. A rectangular athletic field is 200 feet wide. So let's just say, we can let this side be 200 feet. And the other portion of the field is one portion of the field is 5x feet long. So we have this part right here, and they're telling us that a portion of it is 5x feet long. So, let's just say, this is 5x, this portion here. The other portion of the field is 4y feet long. So that would be this part here. So 5x will go up to this point. Four y will cover this point. And we want to create an algebraic expression out of this. So given that we know the formula for the area is the length times the width, let's say that we were looking at the 200 side. Let's just say, for example, it doesn't matter which way this is flipped around. So 200 times what? Right, that's adding these two together. Now, since we cannot combine them because we have different variables, we just write it as 5x plus 4y. All right, and now let's continue simplifying this. What do we have to do? Right, 200 times 5x. So 200 times 5 will give us what? Right. So 1,000, and we join that x in there. And what about 200 times 4? So do plus. So plus 800y, and that would be our expression for in this particular problem.